Hello, today we will be looking at how to solve quadratic equations. This will be part one of a two-part series. So what is a quadratic equation? It is a common term used for polynomials with the degree of 2. If you need a refresher on what a polynomial is, I will link it in the description below. Again, a quadratic equation is any variation of the polynomial with the degree of 2. So if we look at this polynomial, we see that the degree is 2, the exponent, the highest exponent is 2, and a polynomial in this form is considered a quadratic equation. For illustration purposes, you can see that a quadratic equation looks like the graphs I have labeled A, B, C, and D. If you have a graph and the graph only crosses at one point, when you solve the quadratic equation, you're only going to get one solution. However, if you have it crossing in multiple points like we see in D, then you're going to get two solutions for your answer. If it does not cross the x-axis, you will not have any real solutions. You will have a solution, but you won't have any real solutions. We aren't going to get into that today. We will get into it in another video dealing with imaginary numbers. But for this video, we're just going to look at how to solve quadratic equations. And then in a future video, we will talk about imaginary numbers. Let's look at an example where we're trying to solve for x of a quadratic equation. Looking at our quadratic equation, we have x squared plus 3x plus 2. And this follows the form ax squared plus bx plus c, where in this case a is equal to 1, b is equal to 3, and c is equal to 2. So because we are in this form, we do know that this is a quadratic equation. If you've been following my channel, I have already created a video on how to factor polynomials, and I will link in the description below a video of that. Factoring the equation is one way of solving a quadratic equation. Let's use this example for how to solve a quadratic equation. And in this case, to do that, we would just need to set this equation equal to 0. Now with factoring, we're going to get x plus 1, x plus 2 equals 0. And now what you need to do is you can solve each of these quantities and set them equal to 0. So when x plus 1 equals 0 and when x plus 2 equals 0. Now, why did I pick these quantities? Well, we know if this quantity is equal to 0, then this quantity multiplied, no matter what it is going to be multiplied by 0 and therefore will yield a 0. So that's why we want to find out when both quantities are equal to 0, and this is going to correspond to when the graph intercepts the x-axis. If we solve our first equation, we have x plus 1 equals 0, move the 1 over, x equals -1, that's one answer. And we look at the second equation, x plus 2 equals 0, solving for x, we get x equals -2. And these are the values of x when they intersect the x-axis. If you want to check, you can plug this back into the equation. So when x equals -1, we have -1 we have -1 plus 1 multiplied by a -1 plus 2, and that's supposed to equal 0. Here gives us 0 multiplied by 1, which equals 0, and we know that 0 equals 0, so this is a correct answer. If we want to check our next answer, we would plug in the -2 into x, so we get -2 plus 1 multiplied by -2 plus 2, and that's supposed to equal 0. We get -1 multiplied by 0, which gives us 0, and then we understand that 0 equals 0, and therefore we have confirmed that this answer is also correct. Because I've already created a video on how to factor, we're not going to look at this method. I just wanted to show you that factoring, if possible, is a very simple way of solving for x when dealing with quadratic equations. But for this video, we are going to focus on completing the square. So let's look at that. Before we get into solving problems for completing the square, I wanted to go over a step-by-step process to help you complete the square. I have broken down this into 4 easy steps. We are looking at a quadratic equation, which is a polynomial with a degree that has a value of 2. From there, step 1, we want to ensure that the coefficient in front of x squared is equal to 1. If it's not equal to 1, then you need to manipulate the equation, which typically is as easy as dividing each term in the problem by the coefficient in front of x squared. So for example, if we had 8x squared plus x plus 1, then we would need to divide everything by 8, so we can get x squared plus 1 over 8x plus 1 over 8. We want to ensure that the coefficient in front of x squared is equal to 1, and that is step 1. Step 2, you need to manipulate the equation so only the x values remain on the same side. And so what we see here is we have moved the c from the left to the right. And we did this by subtracting from each side c. So if we subtract c from the left side, minus c, and we subtract c from the right side, because if we do something to the left side, we have to do something to the right side, then that gives us ax squared plus bx, which is equal to negative c. Again, we are trying to get all of the x's on one side. The reason why we do this is because of step 3. And step 3 is completing the square. To complete the square, the rule states that you add the square of half of the coefficient of x. In this case, the coefficient of x is b. We have to add the square of half the coefficient. So we take b divided by 2, which is what we have here, and then we square it. And that's how you complete the square. And we need to add that both to the left side here and to the right side here. And so if we do it to the left side, we're going to be left with ax squared plus bx plus b divided by 2 squared. And on the right side, we're going to be left with c plus b divided by 2 squared. So that is, again, the left side and the right side. We have the left side here, and we have the right side here. Similarly, if you have a negative, so right now we've been looking at ax squared plus bx. If we have ax squared minus bx, you're going to do the exact same thing. You're going to add half the coefficient of b squared to both sides. So if this, in this case, we would have plus b divided by 2 squared, same as what we had up here, b divided by 2 squared, and then you're also going to do the same on the right side, which is c plus b divided by 2 squared. And then after we've complete step 3, which is completing the square, we're going to go to step 4, which is solve for x. Now this might seem a little complicated, but let's put a couple numbers to it and I'll show you how easy it is. If we go back to our original problem where we had x squared plus 3x plus 2, we're going to try to complete the square and solve for x. So in this case, we do need to set it to 0. We understand that this is a quadratic equation because the highest degree is 2, which is what we have here. And so with completing the square, it states that we just need to work with this front half, and this front half being ax squared plus bx. So to do that, we just need to move this value over, the c value, over to the right side. And so we can do that by simple subtraction. If we do that, we're going to get x squared plus 3x equals negative 2. Okay, now we need to complete the square. So the rule states that we take b divided by 2 and then square that, and we need to add this value to the equation. If we add to the left side, then we need to add to the right side. And again, this makes sense because if we have 1 equals 1, if we add 2 to the left side here, and we do 1 plus 2, that's going to give us 3. Now the only way this is going to be equal to 3 is if we also add 2 to the right side as well. And that's exactly what we're doing with this problem here. We're adding this value on both the left and the right side. To do that, all we need to do is take the coefficient of b, which is 3, divide it by 2, and we square that. So that value needs to be added to both the left side and the right side. So we have x squared plus 3x plus 3 over 2 squared equals a negative 2 plus 3 over 2 squared. So if we simplified the right side, then we're going to be left on the left side, x squared plus 3x plus 3 over 2 squared equals, this is 9 over 4 plus, and if we want this term to have the same denominator, then we need to multiply it by 4 over 4, so that's going to be negative 8 over 4, and we add these together. Negative 8 plus 9 is equal to a positive 1 over 4. Now, with this, we also know from our rule that this can simplify down to x plus 3 over 2 squared. And again, we're using plus because plus is out in front of the b coefficient. Okay? If you wanted to check your work, all you'd have to do is just multiply it out. So x plus 3 over 2 squared is going to give you x squared plus 3 over 2x plus 3 over 2x plus 9 over 4, which again is equal to 3 over 2 squared. This is x squared plus 6 over 2 plus 3 over 2 squared. 6 over 2 is 3, so x squared plus 3 plus 3 over 2 squared. And that's exactly what we have here, so we know that this is the correct term. Now all we need to do is solve this equation for x. So to do that, we take this, to get rid of the square, we have to take the square root. We have x plus 3 over 2, which equals plus or minus the square root of 1 over 4. If you're not familiar with square roots, I will link a video in the description, and it further goes into the particulars of why you need the plus and minus. The next step, we need to bring the 3 over 2 to the other side. So we have x equals plus or minus the square root of 1/4 minus 3 over 2. Now if you wanted to check your work, you can do negative 3 over 2 plus the square root of 1/4, and you can do negative 3 over 2 minus the square root of 1/4. When you do this first problem here, you're going to be left with negative 3 over 2 plus the square root of 1/4 is 1/2, and that's going to be equal to a negative 2 over 2, which is negative 1. Now, if you remember when we factor, one of our answers was negative 1, and so this checks out in both methods. Looking at our next equation, we have the negative 3 over 2 minus the square root of 1/4 is 1/2, and that gives you a negative 4 over 2, which is equal to negative 2. Which again matches what we got in our previous problem when we factored. So if you complete the square, if you factor, it's all the same thing. You're going to get the exact same answer. However, if you're unable to factor out your problem, then using this method may prove beneficial. Let's look at one more example. Okay, looking at our last example. Now this looks slightly different because the coefficient out in the x square is not 1. In the previous example, we had a coefficient equal to 1. However, when completing the square, if you ever see a coefficient in front of the x square that is not 1, we need to manipulate the problem so that we only have a coefficient value that is 1. So to do this, all we need to do is divide each term by that coefficient of a, or in this case 4. So if we look at this problem and we divide everything by 4, then that's going to leave us x squared minus 3x minus 11 over 4. So now everything becomes normal. What we need to do is we set this equal to 0. We need to move this value over because we only want to work on the left side with this part of the equation. So what we need to do is add 11 over 4 on this side, and we also need to add 11 over 4 on this side. When we do that, this cancels out, and we are just left with x squared minus 3x, which equals 11 over 4. Okay, now what we need to do is we do b over 2 squared to complete the square, and we add this to both sides. So when we do that, we're going to get x squared minus 3x. We take 3, so that's going to be plus 3 divided by 2, because we took b divided by 2, and we square that. And now we have to do that to the right side as well. So we have the 11 over 4 plus 3 over 2 squared. Okay, when we simplify this side, that's going to give us 3 times 3 is 9, over 2 times 2 is 4. So we have the exact same denominator. So now all we need to do is 11 plus 9, because that's equal to 4. And so 9 plus 11 is equal to 20 over 4, which can be reduced down to 5. So we can rewrite this as x squared minus 3x plus 3 over 2 squared equals 5. All we need to do is evaluate the equation. So we can rewrite this as x. This is a minus sign here, so we need to ensure that we have the minus sign down in our equation. And we have the 3 over 2, and that's squared, and that's equal to 5. Again, if we wanted to check this, we could FOIL this out, and we can go x squared minus 3 over 2, x minus 3 over 2x plus 3 over 2 squared. This is going to give us 6 over 2x, which is going to give us 3x plus 3 over 2 squared plus x squared, which is exactly what we have here. So we know that that's correct, equals 5. Now all we need to do is solve for x. So we have x minus 3 over 2, which equals plus or minus the square root of 5. Solving for x, we have x equals 3 over 2 plus or minus the square root of 5. And there you have it. If you've learned something, please like and subscribe. If you have any questions, leave them in the comments below, and we'll see you next time.